All right, we're back for the second lecture in today's or this week's series. This lecture will talk a little bit about erosion and some of the processes by which material is removed from the landscape to then to be available for transport into the depositional environments. This is going to be a pretty brief component of the lecture. We aren't going to go too much detail because these processes are not necessarily not relevant, but we'll cover a lot of the details of more of these processes because they kind of tie into a lot of the depositional environments. So we'll cover them quite a bit more later as they become relevant to the stratigraphic aspect of things. As mentioned in the previous lecture, erosion is the movement of the weathered material away from the site of the weathering, which serves a dual purpose. One, it provides that material to the transport system to then be sent downstream or wherever, so that it can then be deposited for us stratigraphers to look at. But also, the movement of weathered material often makes by erosion often makes more surfaces available for weathering to take place, right? So a system that weathers very heavily, potentially, but doesn't have any transport of that material can actually slow down the weathering process as a function of the accumulation of what becomes soil or saprolite, right? So we won't go into too much detail of that, but some of the weathering processes or the erosion processes are what we'll cover in this lecture. And we'll cover a lot of these in more detail as the course goes on. So the first one that we'll talk a little bit about is glacial transport. Again, we'll have a whole section on glaciers. So glaciers can both be the agent of weathering, right? They can grind material up and abrade and create smaller particles, but then they can also move those small particles out of the system, right? So in this case, here's an example of the same image from before of Schoolroom Glacier, where the abrasion is going on right here, and it's being then transported and piled up this material onto a moraine here at the foot of this glacier, right? And so glaciers can be very, very effective at both weathering and erosion processes, as both agents of weathering and erosion. Okay, well, here's just another example of a glacial transport system on Baffin Island. Again, you can see this is the region which the material is being weathered and then eroded away from, right? So the weathering is taking place by abrasion of ice on those particles, right? And then those particles are being transported or eroded down into this valley here, where you see there's a gorgeous moraine built up here. Okay. Other processes can include rockfall. So here's a great example of rockfall from Zion National Park. This is a really spectacular example. So as a function of thermal expansion and so forth, these rocks are breaking apart slowly, right? And every once in a while they catastrophically fail, like in the example of this video here. So that's a pretty spectacular example of an erosional process that works a lot quicker than most, but can be very effective at moving material, in this case down towards the river valley, where it can then be transported out of the system by the river, right? So this rockfall process that was started by the weathering process of thermal expansion that broke the rock up into fractured pieces. When they fell from their original location, that became an erosional process, which then deposited all of that material down into the riverbed, which can then be eroded and transported further down, right? So there's some other examples of rockfall. It's a relatively common process in steep environments where there's high potential energy based on the slope, right? So these steep landscapes have the high potential for producing rockfall. In this case, this is El Capitan, again in Yosemite National Park. Rockfalls on El Capitan have killed a number of climbers over the past several years. So it's also a very real hazard in a lot of regions. Sort of moving a little bit further down are landslides. This is a very spectacular example of a landslide that can result, that is an erosional process that's moved material, soil off the hill slopes, downslope, in this case straight to the ocean. This is in Big Sur, California. That's Highway 1. And this one, I believe, was from 2017. Of course, just this last week, California experienced another very large rainfall event that saturated the soils in a lot of places after big wildfires, and more of these landslides and mud flows and so forth have occurred along the coast just in the last week. I apologize, it sounds like there's a leaf blower going on in my neighborhood. It's just the joys of doing this from home. So again, landslides can happen in many different environments, generally steep slopes. In this case, this is an area that appears to have burned at some point in the recent past in Wyoming. This is an image from the Wyoming Geological Society, Wyoming Geological Survey, sorry, where the landslide has, in this case, removed material from up here on the slope, and it's being deposited down here in the river valley, which then makes it available for transport downriver. Along this same continuum are debris flows and mudslides. This is a beautiful example of a debris flow on the Col du Saran in France. I believe this was in the Pyrenees. And this actually was a really spectacular one. I mentioned in my little intro that I'm really into road biking. So this was sort of one of those situations that combined my two favorite things in the world, sediment transport and cycling. This was a debris flow that occurred in a big flash storm that ended up stopping the race. The race was in progress, about to come to this part of the route, and they had to cancel the stage, the race mid-stage, because of a big debris flow that occurred in 2019's tour. It was really cool. Here's an image or a video of that happening, so you can see this is the little canyon that the debris flows were coming out of. You can see the boulders and cobbles. Sorry. You can see the debris flow moving as a fluidized mud, basically, and they can transport enormous material, house-sized boulders sometimes out of these things. So this is a really cool example of that. There just happened to be a lot of people there filming it because it was, one of the larger sporting events in the world. Other processes include soil creep. So by a number of different ways, soils on hill slopes can move very slowly downhill. This can happen, it's a diffusive process. It happens very slowly. It rounds out landscapes as these soil particles move ever so slightly by different mechanisms. Their average movement ends up going down slope, and so it's a slope dependent process, which ultimately results in a curved diffusional profile of a landscape over time. This can happen by processes like rain splashing. So if a raindrop splashes on a hill slope, the soil on average that gets ejected by the raindrop will generally be more towards the downhill side than the uphill side, so that'll result in movement downhill. Burrowing of animals can result in movement of sediment and soil downslope. Other things like freeze thaw of the soil, right? So that, which we talked about, was something that can result in a weathering process of breaking down particles, can also result in an erosion process as the freeze thaw moves the sediment, moves the soil to move apart and towards each other as they, as the thaw occurs. They'll tend to move downslope rather than upslope, right? And so that'll slowly cause the soil to creep downslope as well. So that's actually a very, very effective albeit slow erosional process, but it's relatively ubiquitous across Earth's landscapes. One really cool one that I just show because I think it's a really neat process, but it also can be a very effective agent of soil mass movement downslope, and those diffusive processes is called tree throw, where if a tree, sounds like the start of a riddle or something, if a tree falls in the forest, right, its root cluster will uproot a bunch of soil along with it, right? And even if that tree falls uphill, the geometry or the mechanics of it, when the tree falls, it'll uplift a bunch of material, then that material will then drop over time out of the tree's root cluster onto the ground. On average, it will start to fall down the slope. Okay, and so that can result in erosion downslope as well. And then finally are the processes involved in fluvial transport, which we're going to focus quite a lot on because fluvial transport systems form a lot of the sedimentary record and are a very effective conduit of clastic and dissolved material from the uplands of the landscape down to the depositional environments. Okay, so fluvial processes move a tremendous amount of sediment globally, and are responsible for a significant amount of the erosional processes. So that was just sort of the lightning round overview of some of the erosional processes that occur. Like I said, for the ones that are most relevant to the stratigraphic and the depositional world, we're going to go into much more detail on over the course of the semester. But I just kind of wanted to give you a little bit of an overview of where things were going and how material gets transported from those weathering sites to the ultimate end of the depositional systems. Okay. So next week we will start talking about sediment transport and some of the transport processes in predominantly in river systems, and some of the features that you get when you end up in a sediment transporting environment. Okay, so with that I will leave it there, and I will see y'all next week.